Hello and welcome to this course on building AI agents with small agents. My name is Johannes, and this course we are going to explore both the theory behind AI agents and get some hands-on experience building one with the help of the small agents framework that was recently published by Hugging Face. So let me quickly outline what you can expect from this course. We will start first with the fundamentals so that we have a baseline what AI agents are and how they differ from traditional LLMs. And then we map this theoretical knowledge and actually implement a real agent with the help of small agents. So the goal of this course is clear. At the end of it, you should have a theoretical understanding of what AI agents are and also are capable of implementing one with the help of small agents. Enough talking, and I would say let's directly jump into the first section. Before we talk about AI agents, we quickly need to talk about large language models. So let's quickly recap what an LLM does for us. So we give it a text input, the so-called prompt, and then we get some text output back. And it can do it because it was trained with a lot of data during the training phase, and it makes a prediction based on patterns it learns. But these LLMs, they are really powerful, but they are limited. And one key limitation is the ability that they cannot interact with their environment. So they cannot. So let me quickly show you this here. For example, I asked Claude to analyze this GitHub repository for me. And the answer was that it's simply not capable of doing it. But what it could do is to analyze the README file when I could copy this over. So we see these LMs are in a way passive. They can give us some instructions, but these instructions, we need to execute them for the LM. In this case, I need to go over to this repository, grab the content of the README file, and then paste it in. But there's something interesting going on during the last months. And you maybe noticed this, that ChatGPT and Claude have some kind of capabilities. So for example, ChatGPT can search the web for you, and both of them also can analyze your PDFs file and create and execute Python code. So here, for example, when I ask exactly the same prompt to ChatGPT to analyze this GitHub repository for me, we see here this searching the web. And then afterwards, I've given here my response exactly what I wanted. So analyzed this GitHub repository for me. And it could only do this because of this web search capability. And this, you see, is now the introductions from an LLM to an AI agent. And this is exactly what an AI agent is. It's an LLM with its capability to deal with its environment. So having tools on it, like a web search API call, and also dealing then with these responses then, because it has some kind of reasoning. So for example, when it gets back this content, then it can further analyze what to do. So, and while LLM is more passive, an AI agent is more active and can achieve its goal by dealing with its environment. But let's have a more formal definition on the next slide. So, what is an agent? An AI agent is a system that combines an AI model with the ability to interact with its environment to achieve a specific goal. And think of it as having two essential components. We have the brain. So the brain is implemented using our large language model. And this is where the reasoning happens. It handles planning through what's called react, reasoning and acting, and makes decisions about which actions to take. And because of this decision-making role, the brain is also often called the router. So it routes requests to the appropriate tools. And then we have the body. So the body represents everything the agent can actually do, its ability to interact with the environment. And this is defined by the tools and actions available to it. And some common examples include internet search, database access, Python code execution, or code execution in general, and API calls. And there's an important relationship here. So because action, or often also called skills, can utilize one or more tools to achieve the goal. For example, when we have an internet search capability, we have then the search tool and also a URL fetcher tool that are combined together. And this brain-body architecture is what transforms our passive text generator LM into an active, goal-oriented agent. So the LM provides the intelligence, and the tools provide the means to perceive and act. Okay, so let's have a look again on the definition. An AI agent is a system that combines an AI model with the ability to interact with its environment to achieve a specific goal. But how to reach that specific goal? Think of it. What would you do as a human to achieve your goal? You probably first think about it, then have a look on the circumstances and the details maybe, and then you would come up with an action plan. So you need to make several small steps to achieve your goal. And some people's, they like to plan ahead in more detail. And some other people, they're more spontaneously and they decide and take the circumstances as they come. And that's exactly the same that we can do with agents. So we have two extremes here on the spectrum. On the one hand, we have the workflows, and on the other hand, they are the agents, the real agents. And I want to make something clear because at the moment on the internet with the AI agent hypes, you hear it a lot of that they are like agents in production somewhere. But what is actually really doing under the hood is an agentic workflow and not the real agents. But we will get there in a second. So on the one hand, we have the workflows, and at the other hand, we have the real agents. So let's first start with the workflows. The workflows, they are defined by you as a developer. So you basically plan out the steps to achieve the goal of an AI agent. So we can see here an example. We can simply do it with maybe prompt chaining. This is a very fundamental thing that you can achieve. So while we then split up a goal into smaller tasks in an LM call, and here the LM is embedded in predefined code paths. And then we can move it more into the spectrum where the LM directs the control flow. So the LM has some flexibility to choose in their possibilities of paths. So for example, with a routing approach, evaluator, optimizer, orchestrator, worker. And then really on the final spectrum, on the right side, we have the real agents that are the LM directs its own actions based on the environment feedback. So the LM decides on its own what steps to take and also depending on the response that they get back, what to do to achieve its goal. So it's really important. I wanted to really highlight this section here because I think it's important to understand that most of the AI agents you see today, at least, are not really the real AI agents. They are the AI agent workflows. So on this slide, I quickly recapped the key characteristics of a workflow and an agent. So we will not further go into this, but we will have a look here when you should use workflows over agents. So as you can imagine, workflows are best when you have very critical situations to manage, then use workflows because then you can rely on your structure that you defined. And when a task follows consistent patterns and you can predict it, and use agents when you cannot really predict it beforehand, when you need the agents to be creative and use its own capabilities to solve it, and when during the calls, so maybe when different users come with different requirements, then it would be best to use then a more agentic approach. Okay, now that we understand individual agents, let's explore what happens when we combine them together and then we get a multi-agent system. And before we start, let's start with a nice quote by Gary Keller. Multitasking is merely the opportunity to screw up more than one thing at a time. And this insight applies also perfectly to AI agents. So the idea is, rather than having one complex agent that tries to do everything, we break it down to specialized agents that work together. And let's see the characteristics. So each of those agents has a specialized system prompt. So you can imagine this with this is basically a job description for each agent. So a research agent might be instructed to find comprehensive information, while a coding agent might be instructed to focus on writing clean, efficient code. Then we have the dedicated toolsets for each agent. So this is quite clear. So for example, a web agent only has access to the web search tool, while the coding agent only has access to the Python interpreter tool. Then we have the information flow. So basically, one agent can work with the result of another agent. So for example, we have one research agent that scrapes the web and then pass it down to another agent. Maybe this agent is then an analyst agent that gets then this content, this raw content, and can further work with it. And finally, we have the memory isolation. So each agent has its own context and memory, preventing confusion between different tasks. Let's have a look here on this example where we have a manager agent, and his goal is to break down complex tasks into smaller ones and then can delegate the task, for example, to the web agent with a specialized system prompt. You're a professional web researcher if the website is broken and so on, and with the dedicated toolset and in the code agent. And yeah, as I mentioned, the manager agent can pass down the task and we can then further give the results back to the manager agent. So this is only one kind of collaboration methods. There are also different, as we can see here. So for example, we have seen now the first one where we have a manager agent that delegates the task. Then we have also the parallel one where multiple agents work simultaneously on independent subtask. Then we have the sequential one. So they work then in a pipeline. And then we have a competitive mode where multiple agents attempt to do the same task and the best result wins. So in this slide, I wanted to quickly highlight other frameworks next to small agents so that you have a starting point which frameworks exist out there. We have, for example, GradioUI, a nice startup where you can easily spin up multiple agents. Then we have AutoGen by Microsoft. We have LangChain and LangGraph together. We have LlamaIndex by Meta. This slide has the title "Keep It Simple." This is should always be your goal. And with this in mind, Anthropic released this blog post about building effective agents last year, and I really encourage you to read this article. Let's quickly dive into what they write. So in this blog post, they share what they've learned from working with customers on building agents ourselves and give practical advice for developers on building effective agents. Because what you need to know is that these frameworks that I just pointed out, or in general, always brings a kind of abstractions with it. And this abstraction is in the beginning helpful for you building agents, but this is only one part. The other part is, of course, deploying and then also monitor these agents in production. And with this kind of abstraction comes the trade-off of actually understanding what's going on. And therefore, oftentimes, you're actually better off with simple LLM calls at all. So let's look further what he has written. So when and when not to use agents. So when more complexities warrant, workflows offer predictability and consistency for well-defined tasks, as we already know. So for many applications, however, optimizing single LM calls with retrieval and in-context examples is usually enough. And they also then point out to some methodics that you can use. So for example, the prompt chaining that we also shortly discovered, is where you decompose a task into sequences of steps where each LM call proceeds the output of the previous one. Yeah, so I really highlight this blog article by Anthropic to give you best practices from the start when you build AI agents. So enough talking with the theoretical part. We jump now over to the small agents part, where we first need to also cover some slides, but then I promise we will get our hands on and build our first agent. See you there. So it's time now that we dive into small agents, a small library to build great agents created by Hugging Face. And let's see what makes them so good. First of all, it's simple and yet powerful. So for building agents, we only need two components. We need a language model and a set of tools. Let me show you this example. Here we define the model, in this case, Llama 3, and the tools. In this case, we don't use any tools here for this agent, and then we can run our first agent. So this whole library contains only 1000 lines of code, and their goal was to keep it powerful, but also keep the abstraction to a very low level. Then we have flexible model integration. You can work with various LLMs providers, for example, Hugging Face, LiteLM, Azure, or local transformers. So Hugging Face, LiteLM, Azure, these are all providers that host these different models for you, and they also give you a unified approach to use these different models. If you in the past maybe played around with the Claude API, OpenAI API, the Gemini API, with their SDKs, you notice that they behave differently in the usage, so how to use them. And with these providers, they give you one unified API or SDK in this case, and it makes for you as a developer really easy to swap out one model with another. And you don't actually need to care about how to host them, give it enough specs. These providers will do it for you. Then we have a code first approach. So this is really unique here for small agents. Agents write Python code for the instruction instead of JSON. But we will have a later look at this in more detail. Then we have built-in tooling. So this library comes with a bunch of tools ready to use for you. For example, web search, code interpreter, and transcription. Here we see an example where we import the DuckDuckGo search tool and then can use it. And the great part is you can also use tools offered by LangChain and even MCP, so the Model Context Protocol by Anthropic. And of course, we have the ability to create our own tools. This is really important, and it's actually really simple. With small agents, we have there two approaches. One is with simple function decorators. You can see it here, the tool decorator that we need to place above a normal function, and then that's basically next to these descriptions, and that's basically all we need to do to create a custom tool. What else do we have here? Yeah, we have the capability, of course, to build easily multi-agents and then also let them collaborate with each other. So in this scenario here, we see our web agent that has a DuckDuckGo search tool. And we see here a manager agent where the manage then the web agent. And what is also really great is we get some built-in interactive visualization. Usually when you develop and debug your agent, you do it on your code editor or in the terminal. But here we have the opportunity to connect our agent basically with a user interface with the help of Gradio, and then can run our agent and get more visually this information done. And this is actually easy to achieve. The only thing that we need to do is here wrap the agent here in the GradioUI and then simply launch it. So it's time to create our first agent. Let's quickly recap what we need. I guess you already know it, right? We need only the model and the set of tools. Again, I've listed here small code snippet. And yeah, let's jump directly into the code editor and get our hands on by building our first agent. So if we open up here the repository, GitHub repository from smolagents, we see that we need to install here smolagents with pip. And I want to use this chance to introduce you to UV, which is a Python packager and project manager written in Rust, and it's incredibly fast. So a single tool to replace pip, pip tools, pipx, and so on. And here, if you are on Linux or Mac, you can install it with this command. If you're on Windows, then you need to use your PowerShell. So let me quickly grab this command here. Then we go over to our code editor, into the terminal, and then I will run this curl command that will then execute this install script. And then we see, great, now everything is installed. We see here UV, UFX. And what we now do is to create our Python project with UV. Therefore, we type in UV init and then followed by the folder name. So I will call this the first agent. And then we see initialize project. We also see that some files were created for us. For example, also the PyProject toml file. This is then internally used for UV to give some information about the project and also handle the dependencies. And now let me show you how easy and how fast it is to add a dependency. So we type into the terminal UV add and then smolagents or any other Python library you would like to add. Oh, yeah, sorry, my mistake. Of course, we need to first navigate into the folder and then again, UV add smolagents. And we see a lot of things were also now installed next to smolagents. This is because it maybe then appear dependencies to it. And we also see that automatically our virtual environment was created for us. Great. And we see that the Python interpreter in this case is getting used with version 3.10. Cool. So now let's again move over to the GitHub repository. Then we copy this snippet here where we create our first agent because I'm too lazy to write it down. And then we move here to our main file. We copy everything over, save it. And now let's see if we can run it. Therefore, we type in uv run main.py. And we see a lot of red arrows here. Okay, one thing is actually great because of this output in this format, we see that smolagents is correctly installed and working, but we see unauthorized for URL router.hugging face. And it's because we use this Hugging Face API model. So this model is deployed on the remote side of Hugging Face, and we first need to authenticate ourselves to actually use this model or have the access to use it. And this is really simple to achieve. So let's move over here to huggingface.co. Make sure you create an account. I've already done that. Then we click here on our avatar image, move over to access tokens. We create a new token with this button, give it a name. And here you could also manage the permissions for this token, but I will only go here for the read scope, create a token, great. Then you can see this token here, let's copy it. And what we then do is to create in our project a .env file with the key name of hf_token. So this is the standard key where then smolagents can look it up. And then we try to run it again. And usually the standard model is Gwen2.5 coder if we don't specify it here. And I guess it's now working because, yeah, we needed to wait a little bit and we can see then here the output of this web search result agent. So it's actually now interesting to know how the agent come to this end result here of 9 seconds. And the agent, of course, then needed to come up with a plan to achieve this goal and then to use different action steps. And when we see here the logs in the terminal, we understand better what happened under the hood. First, the agent needed to make a web research to actually know what this here is. So this is a bridge and then how long it is, how fast the leopard is at full speed, and then at the end doing some calculation here with this Python code. And all these instructions are written down in Python code, and this is exactly now what we have a closer look on. So, how to deal with actions? Let's recap. An agent achieves its main goal by executing multiple actions. Actions usually use one or more tool calls to achieve the action goal. And these actions, also called instructions, can be written down in two ways. First, we have the JSON format. Here, the instructions are getting generated as JSON. Here, for example, we see the first action, lookup race Germany. Then we see the whole tool call specification then in the JSON format. And here, the tool calling agent is responsible. And then we have also the way of generating these instructions as code. And there, the code agent is responsible. And here we see a completely different approach. First, we define the countries, then the final prices, then we loop over the countries, make some function callings, and then finally print out the result. Okay, now so we have these two. And now, or JSON or code, what is better? And traditional approaches use a JSON format to specify tool names and arguments as strings. And LM must parse the JSON instructions first to understand which tool to execute. But research shows that tool calling LMs work more effectively with a code directly approach. Now let's investigate why this is. So the first major advantage of code-based actions is composability. When LMs generate a JSON, each tool call is isolated and discrete. You can easily combine tools or use the output of one tool as an input to another without additional orchestration logic. So let me show you what I mean with this. Here we have two tools, fetch weather and send notification. And the LLM first needs to call the fetch weather with the parameter New York, then gets back an answer. And then with this answer needs to call again send notification to actually then send the notification. But with code, it's so much naturally and easier to do. We simply call fetch weather, and then afterwards we make our condition check, and then simply call the send notification. The second advantage is much more elegant handling of complex objects. So JSON struggles with representing complex nested structures, binary data, or references between objects. But code naturally works with rich data types like images, audio, data frames, or custom objects with methods and properties. The third key advantage is generality. So JSON tools specification require predefined schemas. You have to anticipate and define every possible action your agent might need to take. And with code actions, the agent can express any computational possible task. It can define new functions on the fly, implement algorithms from scratch when needed, and adapt to novel situations without requiring predefined tools. And this is particularly powerful for complex reasoning tasks. For example, if an agent needs to solve a mathematical optimization problem, with JSON, it would need separate predefined tools for each mathematical operation. But with code, we can simply implement the entire solution like this. And finally, code actions leverage what LLMs are really good at. So these models have been trained on high quality code. They understand programming patterns, API usage, debugging techniques, and so on. So therefore, it makes completely sense since LLM was trained on huge amount of code to actually then use code to describe the actions. So in summary, we've discussed now these key advantages here. These key advantages here, and small agents use CodeAgent as a default agent, but still provides you the Toolcalling agent, since it can be useful in some narrow cases where you can do fine with only one tool call per step. So the CodeAgent is the way to go in small agents as the default agent, and let's have a closer look how this works here. So the CodeAgent is writing its instruction in Python code and then also executes this code on your machine, with your local machine. But this raises the question, okay, this is fine during the initial development locally, but how should this be then done when we deploy the agent in production? Great question, and therefore you can use something like E2B. And E2B is an open source infrastructure that provides secure and isolated sandboxes in the cloud where your agent then can execute the generated code. Yeah, generated code, this sounds a bit scary. I understand you, but this was also considered by Hugging Face team that crafted small agents, and therefore the Python interpreter doesn't allow imports by the default outside a safe list. So we have a default safe list with imports that are always allowed, like print, math module, and so on. You can authorize additional imports by passing the authorized modules as a list of strings and arguments. So here we see the code agent, right? And then here with this parameter, additional authorized imports, we can specify additional libraries we see as safe, for example, request and beautiful soup, for example. Okay. So, and then with this in mind, only trusted libraries can be then generated and also executed. Okay, so we learned a lot about the code agent and the actions, how it's handled internally in small agents. So we know that the code agent is writing its instruction into code, and we define our safe code by allowing additional libraries to be then getting executed on our local machine and then also in the remote isolated sandbox if we want to choose this option. Okay, now we have here our previous agent. Nothing special in here, and I've prepared a little exercise for you to now apply this knowledge that we just learned into a practical example. And therefore, we will further enhance our agent to be a weather agent. And this weather agent, we can give a task, for example, to get the weather data from Tokyo and then get the rainy days, and then also can visualize this information in a nice bar chart. And we will do three things here. We will create a custom weather tool, but this tool will not make a real API call. This is just some sample data, but this is enough for this purpose. Then we will allow additional Python library imports. So for the visualization, we will take Matlib as a Python package to use or create these visualizations. And then also we will see how the code agent generates and executes the Python code. So let's get started with defining our custom tool. And we do nothing special here. We just start by defining a normal Python function. So let's call this def get weather data, where we can pass in a city name. So this is of course a string, and we get back a dictionary. And we have two ways in small agents to mark a custom tool. And for easier or simple tools, we simply can use the tools decorator just tool decorator that is coming from small agents. And now we need to describe the interface of this tool. So basically we need to define an interface for the LLM so that the LLM knows the name of the function, the input parameter, and also what the LLM can get back out of this tool call. So yeah, describing just its functionality. And we can do this here with these strings. And here we start by saying, okay, this returns sample weather data for a given city. Okay. And now we specify the args. So the city, this is the name of the city. For example, New York, London, Tokyo. Great. And then that's actually all we need to do. And now let's define our sample weather data. This is just a plain simple dictionary. Here where the key is the city name, New York. And then an object with different attributes. For example, here temperatures for the week. Yeah. Since I'm super lazy and I want to focus here on the important part, I will now copy over what I've prepared. Here the sample data. And then what we finally need to do is here this one where we lower the given city and then use this as a key for a lookup in our dictionary. And we do this here normally with the .get. And if nothing can be found, we have this here as a fallback or an error object. Great. So we now are finished with our custom tool. You see nothing really special here. So just using here the tool decorator and with some description for the LM. And now let's move on to the part where we introduce the agent to this custom tool. So again, nothing special here. We just get rid here of DuckDuckGo search and then place in here our get weather data. That's all we need to do. And now I hope you remember, what do we need to do if we want now an external package to be added to the save list? Correct. Yeah, we use the additional authorized imports parameter. And here we can define our packages. And now I will specify matplotlib. And what I will also do is to increase the logging. So usually the log level is info as a default, but here I will increase it so that we see more information, what is going on under the hood. So, and therefore I will set here the verbosity level to 2. This will give us then the debug level. So we have everything for the agent, right? We can still use the same model. And now let's, we need of course to adjust this prompt here. So I use here what I've prepared. So first I have here print statement, and then this is the prompt, get the weather data for Tokyo, and then calculate the average temperature, count the rainy days, make a simple bar chart of daily temperatures, and then save the chart here with this file name. And don't use this function because now we are here operating a terminal, and this, yeah, I don't know if this would work. Great, and then we see then here the agent's response is then the final response from the agent. So there's one thing I need to mention right before. We can only use libraries here in the agent if we install them beforehand. So the agent is not capable of doing that by its own yet. Maybe this is then possible in the next couple of months, but the agent is not capable of installing them for you. So you need to install it before we can use it. So let's do this with uv add matplotlib. Otherwise you will get an error that this module cannot be found. So let's add this one. Then let's run our agent with uv run main.py. What is going on? Yes, of course, we need to correctly spell this. So sorry. Now it's getting on. Are you excited? And now we see here with our verbose level of 2, the for process of the LM. Step 1, yeah, I first retrieve the weather data for Tokyo, and then I can use here this get weather tool, and I will calculate the average temperature. So The agent is coming on with its plan. Therefore, it writes then some code where it's then using our function with the city equals Tokyo. Very nice. And yeah, it's just amazing. Just go through the logs here to get a better understanding. For each step, we get also the input tokens and the output tokens and the duration. I have to say, a really nice terminal output here for a small agent. Really nice structured. And yeah, let's see then what is going on. Again, some more code. We see it finally again, here's some happening now with the visualization with matplot. Yeah. And then here we have our final answer, the weather analysis and plot saved to the Tokyo Times PNG file. And let's have a look on it. Wow. Isn't this amazing? How cool is that? And yeah. So we have now enhanced our first agent by first using another prompt. We introduced this agent to a custom tool where we use the tool decorator and also the params, the description here, to make it available to the large language model. We also then used an external package with the help of the additional authorized imports to achieve this weather analysis agent. Okay, now with this agent in place, I want to show you two more cool things that we can do. And the first one is adding a UI to it, to the agent in a very easy way. And what we need to do is here from small agent first import GradioUI like this. And then what we can do here is we call here GradioUI simply with our agent in there as a parameter. And then after that, call the launch functionality. That's it. Now we have a UI and we don't need the agent run anymore because we can actually use this prompt and then inject it over the UI to the agent. So let me show you how this look like. Of course, it's very important that you first, of course, add it. So let's do this. UV add Gradio. I've already done this now, but make sure that you've installed it. And now, sorry, my voice, too much recording. So, and now we can run it. UV run main.py. And we see that we got here then a local URL that we can access then. So I will hold Control and then click on it. And then it will automatically open up here in my Chrome. And now we have here a chat message. And in here, I will now paste in the previous prompt. And you know what? Let's actually change this here to New York now. And then let's run this prompt. Enter. And I have to say that the UI is now returning the agent console log information back, but in a very nice way. So let me show, it's still running here. So we need to wait a little bit and then we will see the output of the agent. Okay, now we can see here the output of the agent. Also the first step with the generated code here, step 2. And I have to say this is in a very nice format given back to us also here in a small gray font here, the input tokens, output tokens, and the duration for that given step. Yeah. So I guess model too busy, unable to get response. Okay, apparently there is something going on with our remote model here. But anyway, I guess you get the idea. So now we have our cool agent, we've added the UI, and now I would like to show it to you and also to other people. And yeah, this is then quite hard because I need to upload all the codes to my GitHub repository. Then also I need to share this with you. You need to clone it, set it up locally, and then you can start it and test it out. And wouldn't it be nice if there would be a more easier solution? And there is. Introducing you now the Hugging Face Hub. In the hub, we can create our own spaces. And in this space, I can upload my agent, and you can then easily grab this agent and also then use it. And let me show you where you can find this. So for example, here now we're in this space here of David, and you can see in this space he shared now some cool stuff. For example, this travel planning agent. And this is actually something we did now. An agent uploaded with an GradioUI, and now we can click in here and then also test out his agent. And so I will now not do this now, but just that you get an idea that we can like upload our agent, make it available, visible for other people, and they can easily test it out. And now how can we do this? This is very easy. We just need to call this function here push to hub, and here we need to provide our space name. So the first one is my username on Hugging Face, then followed by the space, how you want to call it. Here we can specify our commit message. Here, if we, what was this parameter again? Yes, here. So let me open up here the documentation, private. Yeah, if we would mark it as a private one, so only you could then see it. And then the next parameter is the token, because of course we need to authenticate ourselves and have the allowance to actually then push something in there. I've created here a token to do this. Otherwise, if you can also, if you log in with the Hugging Face CLI, then the credentials will be stored locally on your computer, and then you do not need this token because then they will grab it from there. But let me show you how to create this token. So again, we need here to go to the Hugging Face side, and then where we created our first API token, so access token, and then here create a new token. But this one, we go here on write, and then you can create here your token. I've already done this, and after the video, of course, I will revoke my token. Yeah, and we need then to specify it here. Great. And now we have everything in place. So we fully defined our agent, and then we use push to hub to then publish it. So to our space, to our own space. Okay. So now let me run this. So UV run shadow pi. So, and then if I going here to my profile page, we see here one space was created, and we see still building the weather agent. Cool. And well, Hugging Face do not stop there. We can also push tools to the space as well. And this is exactly the same. So instead of agent, we just use here the custom tool that we defined. And then let's maybe rename this here weather tool. Our first tool we share, and then let's run this again. And then we should see, yep, here, our weather tool. So this is really cool, because if you spend a lot of brain power and time for building a complex tool, you can make it more generic and then also upload it there and share it with other people, or reuse it then in other agents as well. And now let me show you how, now we pushed the agent, and now let me show you how you can actually grab it. Okay, sorry. So again, we still need this agent here, and then from here we call the from hub. Okay. And now I've created here a new agent, new weather agent, and then still can run it here with our previous prompt. And now I get a message. So this also needs to be trust remote code true. So let's try this out. Okay, so of course, then we need it here from the hub. We need to specify this attribute trust remote code true, and then we can actually then download our agent from the hub. And here I'm getting some errors that I've exceeded my monthly included credits. But yeah, anyway, I hope you get the idea. And so don't forget, you can share agents and your tools, and then can grab it again to use it. Okay, now it's time to actually combine different agents to solve a more complex task. And this is what we will do in this section. We will build a multi-agent system that can do some web research, analyze this content, and then can give us back a final report. And this will be done in this manager worker orchestration mode that we have seen in a slide. So where we have one manager agent that can orchestrate and have a bigger context about the task, and then can delegate the task to a dedicated agent. So for example, one agent is then the web search agent that gathers the information from the web. Then it gets back to the manager, and then the manager gives it then further down to the analyst agent that then works with this content, and then finally give it back to the manager where we then craft the final report. So this would be a market research agent team where we then can ask a question about the upcoming trends, for example, in renewable energy or electric cars, and we get a summary about, hey, is this now a good market to invest or not? Great. So let's first start by importing what we need for this multi-agent. We will import from smolagents again our CodeAgent to actually then write down these instructions in code. So this will be then used by our manager agent. We import DuckDuckGo search, of course, this tool provided by smolagent. We will use here the OpenAI server model. So to finally use an OpenAI model. So for the manager, we will use O3, which is a reasoning model because we need there some more complexity and brain power. And for the other, we will use a smaller model like a GPT-4 mini. And then we will also then see the tool calling agent in action, because in some narrow use cases we learned it makes sense to use it. So for a very dedicated agent with only one tool and one task, it's straightforward, and therefore we can use it. And I think it's actually a nice demonstration to then use it now. And of course the tool decorator, because we will write some custom tools. So again, and then we have here something interesting, Markdownify. So this allows us to parse HTML content into a Markdown format, and this Markdown format is in general better to handle for a large language model. So, and now let's start with our first custom tool. So I will just copy over here and then go through code, because this is then where we can focus on the essential. So this will be then the visit web page tool. Again, you see the tool decorators here. We pass in a URL and get back a string. So visits a web page at a given URL returns its content as markdown string. So we have here normal request sending, and then we use here Markdownify with the response text to get the markdown. This is then what we return in this custom tool. Great. And now let's also write down here the second custom tool. This will be then the analyze sentiment. Here we give in the text and get back a dictionary. And here, this is a very high level and nothing complex sentiment analysis, where we just try to find some positive words, for example, growth, increase, profit, and some negative words, and therefore calculate the overall sentiment. So yeah, just for demonstration purposes. Yeah. So the idea here is to give them back a sentiment if this text that we give in is rather positive, negative, or neutral. And then we give back the dictionary with this attributes here, score, label, positive, and negative count. Great. And then we have our third custom tool. This will be the extract key metrics. We give in a text and again get back a dictionary. And here we extract the key metrics and statistics from the text. So for example, extract dollar amounts, extract percentages, dates, and so on, and then give it back in this with these attributes. So now let's actually now create our models that we will use. We have then our GPT. So we see here now we can use this OpenAI server model to create our OpenAI model here. We use here the GPT-4 mini, and here we need to specify the base API URL from OpenAI, and of course then here the OpenAI key. let me quickly show you how you can grab this. So if you open up here platform openai.com, log in, then go to API keys. You can create here a new secret key, then create a secret key and then shows up, and then copy it over here to the .env file where we already have our Hugging Face token or next to it. And please create here the OpenAI API key with the token you just copied. So, and then we have our reasoning model. So this will be then used by the manager that has the overall context and is responsible for planning the whole task, where we give it the new O3 mini reasoning model. And let me also show you this page here from OpenAI, because maybe you wonder where I get this information here. And here, when you hover over to platform.openai.com, docs models, you see a nice overview for all models. And then if we click here for O3 mini, we see the reasoning, speed, price, input, output in a very nice way. And also what we then actually can do with this model. So not all models, for example, support image generation, fine tuning. And here we can see it that, for example, the GPT-4o, where was it now? The mini is right here. So average intelligence, speed, and with this we can also have some batch opportunity. Function calling is also there. This is important. Structured output. Yeah, this is then where you can see all this information about the model from OpenAI. So now we have our two models. It's time to introduce you to our first agent. This is then our web agent. So for retrieving the market information here, we use the Toolcalling agent, okay, where we then provide in here the DuckDuckGo search tool and the visit web page tool. We specified here the model with the web model, okay, maximal steps, so how many iterations it can take, because in this scenario we need to get information from multiple sources. Therefore, it's okay to specify a higher number because we want to extract from many pages. And again, the name in this description. Then we will create our second agent, the analysis agent. Again, this is a Toolcalling agent. Here we provide the analysis sentiment tool and the extract key metrics. Here we use then the reasoning model. We have the maximal steps of 5. And again, a name and description. And then finally, we set up our manager agent. So this is then the CodeAgent. This is important. We again use here the reasoning models. We have no tools. We have this attribute that then allows actually then the manager agent to have access to these two and then delegate the task further down. So with manager agents, and here we specify the web agent and the analysis agent. And we of course need then some additional authorized imports, the pandas and matplotlib. And again, some name, description, planning intervals, or how many steps planning interval ahead, maximal steps, and verbosity level, so that we can see more debug information during the process. Then what we can also do, this is actually really nice. Let me show you this. We have here the opportunity in smolagent to visualize also the agents and the hierarchy. So let me call this function for you here. So when we run now uv run main.py, we should actually now see all the agents with the tools and their relationship. Okay, maybe not. Oh, okay, I've done here a critical error on the visit web page on this custom tool. Maybe you noticed this. Of course, I have not given the script interface very well. So let me fix this, where we then also then specify the args and the returns, of course. And I also need to do this for the others as well. Shame on me for just copying over so blindly. So here, let's check arguments returned as the text. This looks fine. And again here, extract key metrics and statistics, arguments, returns. Okay, again, some more errors here. Yep, this is now related to intention. So I fixed now everything, and now if we run finally uv run main.py, because I wanted you to show you this visualize function here when we call it from the manager agent. And then what we see is this. So we see here now our code agent, the model that has been used here, the authorized imports, the tool. Then from there we see here the orchestration, manage agent, web search agent, the description, and here the tools. Yeah, with the description and arguments in a very nice way. Analysis agent here as well. Great. And now the only thing that we need to do is, of course, then to now call our manager agent. Let's do this. I will therefore create here a dedicated function called run market research, and there we can specify the industry. And here we then craft a dynamic prompt where we then inject this parameter in. So your market research assistant, your task is to research recent trends in the industry and prepare a market report. Follow these steps. So compile everything into a final report with executive summary with two to three paragraphs, key trends, market sentiment analysis, including both positive and negative perspectives, important statistics and metrics, conclusion with outlook. The report should be concise but comprehensive, focusing on actionable insights, and also include sources at the end of the report from where you got the data. Whew. Okay, now it's time to then call this function. And what should we give in? Because this is a very up-to-date and important topic. Let's just say defense industry. I clear here my terminal. Yeah, and of course, I almost forgot this, but since we are using the OpenAI provider, you need to install also here the smolagents OpenAI package to then actually also use this OpenAI server model here. Okay, so I will do this again. I've already done this just to make this sure. And then let's run our multi-agent research team. Let's go. And since we have set up the verbose level here to the manager agent, we should again see all the thinking process. And here is now he came up with the plan. So request the web search agent to gather recent market data and use in the defense industry from reliable sources. Request the analysis agent to process and analyze the collected data to extract key trends, quantitative metrics, and market sentiment. Organize the analyzed data into the required report settings, blah, 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 blah. So we see to identify in first place the task and then break it down and correctly delegate it to the agent. Here's the final answer. The defense industry is undergoing a transformation period as technological advancement, geopolitical shirtricks. Yeah. And this is also important. Then we see the sources. So let me also quickly visit these websites to see if this is legit or not. Oh, what do we have here? Okay, seems good. Also, yeah. And with this approach, I hopefully showed you how you can combine multiple agents with the orchestration of a manager agent to achieve a more complex task. So let's recap what we actually have done here, the important points. We have created two models with OpenAI, one dumper model with the GPT-4 Mini and a more reasoning model with the O3 Mini. Then we use the Toolcalling agent for a very simple task, dedicated straightforward task. And then we use the manager agent as a code agent with the managed agents to have then these agents in his portfolio to orchestrate the task down. And again, we learned about the manager agent visualize to see this whole group together with their related tools and models. And yeah, small agent gives us here a nice and easy way to achieve multi-agent systems. So up until now, we've been focused on getting our agents to work correctly. But what happens when your carefully crafted AI agent system faces real users with unexpected queries? How do you know if your agent is performing as expected in production? And more importantly, how do you identify and fix issues before they impact your users? And these challenges are particularly difficult with AI agents because, unlike traditional software, AI agents are more dynamic by design. They make dynamic decisions, follow nonlinear paths, and generate massive amounts of logs that quickly become overwhelming to analyze. And today I will show you OpenTelemetry and LangFuse to solve this problem. So OpenTelemetry, if you don't know, is an industry standard for collecting telemetry data, not only in the LLM context, but also in the context of cloud and any other application. And LangFuse is an open source specialized platform for monitoring LLM applications. And together, they provide the visibility we need to effectively monitor our agents in production. In this section, I will walk you through how you then set this up locally and then implement this in your agent so that we have a great visibility, a great monitor at the end that we can check our agents not only during development, but also in production. Okay, then I would say let's get started. So we can see here our weather agent, and we will use this agent to add some cool monitoring. And the first thing that we need to do is to set up LangFuse locally. They provide a really good documentation on the self-hosting part, just visiting langfuse.com/self-hosting/local. And I assume that you already have Docker and Docker Compose installed, since we will need this for this local setup. If you've not done this yet, please pause the video, make sure that you have then installed Docker and Docker Compose for your operating system. Great. The first thing that we need to do for the local setup is to clone their repository. So let's do this. I'm here now in our project folder, and then simply then clone LangFuse and then also navigate into there. And then once we're in the LangFuse folder, we will run the command docker compose up. And now we need to wait till all the services are up and running. I have here a look on my Docker extension and I can see, yep, everything is green. And I would also like to use this chance to present you this useful extension with Docker. It's very simple to get. You only need to go here to the extensions, search for Docker. It's the first one, and then install it. And then you also should see Docker here on your left navigation bar. And now that everything is up and running, let's have a look again on the documentation. Yeah, we only need to go here on localhost 3000. So let's do this. And then we need to sign up. This is really quick. And then we will land here on the landing page where we then create a new organization. So that would be then usually your project, your company name, and so on. So I will choose here Small Agents course. Here we have then the chance to also invite some colleagues, some friends, so that they also can look on the agents traces and logs. And now it's time to define our project name. So we will use here weather agent and then create this. And now we are getting here the secret key, the public key, and the host. So these are all the information we need to authenticate ourselves in order to send that data to LangFuse. So let me show you what we need. I will copy over what I've prepared so far. So we first define here the LangFuse public key and the secret key. And with these two, we will then combine them and then encode our LangFuse auth token that we will then later on use in this part here. So in the environment variable OTel exporter OTLP headers. And later on, this is then responsible that the auth token is then getting added to each HTTP request in order then to authenticate ourselves that we are legit to can ingest data. And another important environment variable that we need to set is this one here, the OTLP endpoint, so on which address we would like to send the telemetry data. And if you use the hosted version of LangFuse, you can use then, for example, this URL, where we then store the data in a Europe data region, but you can also use with the prefix US to store it then in a US data region. But since we are locally, we still stick here with localhost port 3000, and then this is important here, API public OTA. Okay, the second step is now to instrument our small agent to actually use now the OpenTelemetry mechanism. And this is very easy to do. So we first need to import some more stuff. Here we import then the small agents instrumentor. And also we will import the OTWL span exporter. Oh, sorry. And then also from OpenTelemetry, we will import the trace provider and the simple span processor. So I know these terms are quite confusing for you, but we will get there in a second. First of all, we need to finish this. So now after this part where we set up the authentication, we will now create, first of all, a trace provider. So this is responsible for generating unique trace IDs and manage the spans. And then the trace provider, in here we add a span processor. And in there we specified an exporter. And then finally, we connect our small agents library with the trace provider. So this is basically in one line achieved that small agent now by itself to send the logs then to LangFuse with the OpenTelemetry protocol. And now let's have a closer look at what a trace is, what a span is, and so on, because I think it's important for you to know what is then actually happening here. Therefore, I've prepared this little documentation here. So a trace represents the complete journey of a request go through our system. And for our agent, this is the entire execution from receiving a user's query to delivering the final response. And it's identified by a unique trace ID and contains one or more spans. And here we see then the spans. So we have then a root span and there are some child spans. And a span is a single unit of work within a trace. And in agent system, a span is typically represents, for example, a LM reasoning step, a tool call, a sub-agent invocation, and so on. Then we have also the span context, and this is then identifying the information that gets propagated between the components to maintain a parent-child relationship between the spans. And then if we scroll here further down, we see then the span processor. And the span processor handles the spans before they are getting exported. So the processor can filter spans based on certain criteria. They can also add or modify attributes and so on. And then we have then the exporter, and the exporter sends the process spans to our telemetry backend, in our case, LangFuse. And the OTLP exporter uses the OpenTelemetry protocol to standardize how the data is formatted and transmitted. Okay, and with this information in place, let's again have a look on the code that we just defined here. The trace provider here is the core component of the OpenTelemetry tracing ecosystem, and he is responsible for creating the unique trace IDs to identify a complete lifecycle request, and also managing the span creations with the individual units of works in the application. Here then, we add to our trace provider then the span processor. So as we know, the span processor processes the spans before they're getting executed. And what is really important to highlight here is that for debugging purposes, we should use the simple span processor. But if we are then in production and we are generating a lot of logs, we should then use the batch span processor, because then they will combine a lot of spans before then they're getting exported. But for our little use case, the simple span processor is here enough. And in there, we create a new instance of the span exporter. So as we learned earlier, this is then responsible for formatting and standardizing the data in the OpenTelemetry protocol and then sending it to our OpenTelemetry provider, in our case, LangFuse. And here now, with this line, we instrument the small agents library to use it. So this is automatically attaches sensors to all parts of our agent. And once this runs, the agent will be automatically monitoring without you having to add any tracking code in your actual agent implementation. And this is all we need to do in terms of the code. And now let's run this agent and see what we then got here. Okay, so since I've modified here the agent with UI, we will run then uv run agent with UI.py. And now also head over to the localhost web UI. I will refresh. Let's see. Agent is still running. Okay, so I had an issue here with invalid credentials. And this is simply because I forgot to copy over the secret and the public key here. So if you also run into the same issue, you can go here to configure tracing, then copy here the secret key first, scroll up here with the secret key, make sure this is then the correct one, paste it over, okay. And then do the same here with public key, copy it, go here to the public key, and make sure we use then here the correct one. Okay, great. Now at the end of it, we see no error. The agent was successfully. And we also see here our first trace. So remember, trace captures the whole journey of the agent. And here we see consolidated then, if we had more traces, the overall cost, the score, small usage, and so on. But I guess it would be better if you, on your own, explore the UI here and the capabilities. I will only show you then how to get more information on this trace. So we go then here to traces, open this up. And then we click here in this and the first trace here. And you see now all the multi-step, since we have a multi-step agent, you see then here clearly each step, and also can very easily identify also the two cores, for example here, where we put in Tokyo as the city as a parameter and get that back this result. You can also enable here the timeline so that you have a better understanding of each steps when they happened in the timeline. And also from here, when you look up here, you see also the latency, the tokens used, and also which model were used for this step here. And you can also, if you click here, can enable and disable Markdown and also see then the whole messages here in the JSON format. Yeah, that is basically all I wanted to show you in terms of the UI. Don't forget to have a look on your own on this incredible monitor tool that is open source. And that's all. Thank you for watching. All right, everyone, we reached the end of this small course on AI agents with small agents, sadly. So let's recap what we've covered so far. So we began with some theoretical knowledge where we started with the limitations of large language models and from there moved then into the introduction of AI agents. Next, we had a look on the agent composition. So in there you can remember the brain and the body architecture. Then we had also a look on the workflows versus agents. So remember, today's agents are not really full agents, they are more agentic workflows. And then from there, I had a look on the multi-agent system. So when we have bigger tasks to achieve, that we can wire up different dedicated agents to achieve a bigger goal and also the different collaboration methods. Then we transitioned from this theoretical knowledge into the practical one, where we then used small agents to actually implement these theoretical concepts. We started first setting up small agents. There I showed you UV, right? Then we built our first weather agent with also some custom tools. We understood the code agent and also the tool calling agent and the difference, so that the code agent is actually writing its own code to achieve its goal and is getting executed on your local computer on a remote sandbox. And then we implemented a multi-agent system with small agents and finally added some monitoring with the help of OpenTelemetry and LangFuse. Wow, quite a lot. So in these terms, I have to say thank you for your participation. I hope this course was useful for you. In case you want to reach out to me, you can do this via LinkedIn. I would like to, if you have a question or want to discuss something, I'm open to this. And also I want you to encourage to keep learning. So the resources I use is also linked here. I used heavily the documentation and also there's a nice Asian course by Hugging Face itself that you can also participate for free. In these terms, I'm really excited what you're building and hope to see you soon. Bye.